Hello, everyone. Welcome to this training session on Identity and Access Management, or IAM fundamentals. In this video, we're going to understand why cybersecurity matters, where IAM fits into it, and why identity has become the new security perimeter. Whether you're a student, career switcher, or IT professional trying to understand IAM at a foundational level, this session is for you. Before we begin, a quick disclaimer. This video is for educational purposes only. It is not official product training or certification material for any IAM vendor. Everything you will hear is based on my 25 plus years of experience in the IAM industry and represents my professional understanding, not the views of any vendor or organization. For official training or certifications, always refer to vendor documentation. In the previous video, we covered the fundamentals of LDAP, what it is, how it works, and why organizations rely on it. In this video, we go one level deeper. We are going to look at the structure that makes LDAP so powerful, the Directory Information Tree, or DIT. Let's get into it. By the end of this video, you will understand how a directory is structured, how every single user and group gets its own unique address inside that structure, and how the LDAP server uses that address to locate any entry in milliseconds, even across a directory of 50,000 users. In this video, we're going to understand the LDAP information tree. We'll see how users, groups, and resources are organized in a structured hierarchy. Directory information tree is exactly what it sounds like, a tree-shaped hierarchy that organizes every piece of identity data in your directory. Think of it like a company org chart. At the very top, you have the organization itself. Below that, you have departments, and inside each department, you have the individual people and resources. The DIT works the same way, and this structure is what allows the LDAP server to search through millions of entries almost instantly, because instead of scanning a flat list from top to bottom, it follows branches directly to where the data lives. Every single item inside the DIT, whether it is a user, a group, or a department, is called a directory entry, and every entry sits at a specific location in the tree. Now let's walk through each level of the tree, starting at the very top. At the very top of every DIT is the root node. This is the foundation that everything else sits inside. In our example organization, EduServe IT, the root node looks like this. DC equals EduServe IT, DC equals COM, DC stands for domain component. And here is something important to understand. The root of a DIT is deliberately designed to mirror the organization's DNS domain name. So because EduServe IT's domain is eduserveit.com, the root of the directory is DC equals eduserveit, DC equals com. Just like how a website address identifies an organization on the internet, the root of the directory uses that same domain name to identify the organization inside LDAP. Everything in the entire directory, every student, every staff member, every group lives inside this root. It is the starting point for every single search the LDAP server performs. Moving down from the root, the tree splits into branches. These branches are called organizational units, or OUs. Think of OUs like departments in a company office. The HR department is in one section. The IT department is in another. Each department has its own people, and each department operates under its own set of rules. You would not place an IT engineer inside the HR department, and you would not give an HR employee access to the server room. OUs work exactly the same way inside the directory. In our EduServe IT directory, we have two OUs. OU equals students. All students accounts live here. OU equals staff. All staff and faculty accounts live here. By placing students and staff in separate OUs, The directory administrator can apply different rules to each one. A student account will never get the same access as a payroll administrator because the directory keeps them in completely separate containers, just like separate departments in an office. That is all. An OU is an organized container that groups similar identities together so they can be managed separately and securely. Inside each OU, we go one level deeper. Let's look inside OU equals students. You will see two more containers. OU equals people and OU equals groups. This distinction is one of the most important concepts in LDAP design. Now let's talk about the groups container. A group in LDAP is an entry in the directory just like a user entry, but instead of storing personal information like a name or email, a group entry stores one thing, a list of its members. Here is the best way to think about it. Imagine EduServe IT has a gym on campus. Only certain students are allowed in. Now you have two ways to manage this. Option one, you open every single student's file one by one and write gym access yes inside it. That is 5,000 files you need to update. And if a student leaves, you open their file again and remove it. Option two, you create one list called gym members. You add the names of the students who have gym access to that one list. Done. If a student leaves, you remove them from the list. One change, one place. That is exactly what a group entry does in LDAP. Instead of updating thousands of individual records, you maintain one group entry. The gym system checks that one list and immediately knows who is allowed in. That is why groups exist, to make access management fast, clean, and easy to maintain. At the very bottom of every branch are the leaf nodes. These are the actual data records, the individual directory entries that hold real information. In our example, a student entry might look like this: UID equals HIISZ6, object class, inetOrgPerson, mail, HIISZ6 at eduserveit.com. In production LDAP systems, the standard naming attribute for a user entry is UID, which stands for user ID. This comes from the inetOrgPerson object class, which is the industry standard schema for representing a person in an LDAP directory. Every entry in the DIT belongs to one or more object classes. An object class defines which attributes that entry is allowed or required to have. The inetOrgPerson object class, for example, allows attributes like UID, mail, and CN, which is the common name. Because every UID value is unique within its container, the directory will never confuse two entries, even if you have 10 students named John Smith. Now that we understand the structure of the DIT, we can understand how the LDAP server locates any entry instantly. Every entry in the DIT has a globally unique address called the distinguished name, or DN. Think of a DN as the full postal address of an entry. Just like a postal address needs the name, the street, the city, and the country to be unique, a DN combines every level of the tree into one precise location string. Before we look at the full DN, let's understand one building block, the relative distinguished name, or RDN. Each individual component in the tree path is an RDN. For example, the UID equals HIISZ6 is an RDN. OU equals people is an RDN. OU equals students is an RDN. DC equals EduServe IT is an RDN. An RDN is formed by an attribute name, an equal sign, and a value. When you chain all the RDNs together from the leaf all the way up to the root, you get the full distinguished name UID equals HIISZ6. OU equals people, OU equals students, DC equals EduServe IT, DC equals com. Read it from left to right. You start at the most specific level, the individual entry, and move outward to the root of the organization. This DN is completely unique. There can only be one entry with this exact path in the entire directory. That is what makes it a reliable identifier. So now you understand what a DN is, but how does it actually get used when someone logs in? Let's walk through it simply. Think about showing up to a secure office building. At the front desk, you say your name. The receptionist looks you up in the directory, finds your full record, and confirms who you are. Once confirmed, they let you through. LDAP authentication works the same way. When a student types their username and password, the LDAP client first searches the directory to find that student's entry. It uses the username to locate the correct entry and retrieve the full DN, the unique address we just talked about. Once the DN is found, the LDAP client then presents that DN along with the password to the LDAP server. This is called a bind request. It is simply the formal way of saying here is who I am and here is my proof. The LDAP server checks the credentials. If they match, the login succeeds. One important point, this exchange must always happen over an encrypted connection. LDAP by default does not encrypt the data it sends, so it is always secure to use LDAPs, that is LDAP over SSL, to make sure the credentials are never exposed on the network. Think of LDAPs as the difference between shouting your password across a room versus handing it in a sealed envelope. Always use the sealed envelope. Let's bring the whole picture together. The EduServe IT Directory Information Tree has 4 levels. 1. The root DC equals EduServe IT. DC equals COM mirrors the DNS domain and is the foundation of the entire directory. 2. Organizational units. OU equals students and OU equals staff. Separate identities by department and keep each group under its own set of rules. 3. Subcontainers. OU equals people and OU equals groups. Separate individual identity records from group membership records. 4. Leaf nodes, individual directory entries like UID equals HIISZ. 6. The actual data records that hold attributes. Every entry in this tree has a distinguished name, a unique, precise address built by chaining its RDNs from leaf to root. And when a user authenticates, the LDAP client uses that DN to issue a bind request to the LDAP server over an encrypted connection to verify identity. To recap what we covered in this video, the DIT is a hierarchical tree structure that organizes all identity data in an LDAP directory. The root node is derived from the organization's DNS domain using domain components. Organizational units are the branches. They organize entries and ensure each department operates under its own rules. People containers hold individual identity entries. Group containers hold group entries. One list that manages access for many people at once. Leaf nodes are the actual directory entries defined by object classes like inetOrgPerson. Every entry has a unique distinguished name. Built from chained relative distinguished names, authentication uses a two-step process, a search to resolve the DN, followed by a bind request over an encrypted channel. Thank you. See you in the next video.